There are these creatures that came from off-world. These are pariahs. NASA, notable for its fundamental divulgences, has without a doubt uncovered that this new planet isn't simply enchanting, considering the reality of its size and locale, but additionally because it shows lights that appear to be artificial. Are we, all things considered, uncovering insider factual realities that could have an impact on our perspective on the universe? Could this discovery mean there is life on various planets? Join us as we explore NASA's beguiling disclosures and uncover the truth regarding these stunning lights. In 2007, NASA launched the Dawn spacecraft with a mission to examine the most enchanting objects in our nearby planetary system. Dawn was brilliantly equipped with 3 ion engines, allowing it to undertake an extraordinary journey. Dawn's trip began with a 14-month evaluation of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data, revealing Vesta's perplexing surface and diverse geological history. Following the completion of its primary mission at Vesta, Dawn set out on the second, and perhaps most captivating part of its journey, a close examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and set a determined course to reach Ceres, an achievement that conventional chemical propulsion would have found challenging. These engines provided a consistent, gentle push, enabling Dawn to travel vast distances efficiently and enter a stable orbit around Ceres. First discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For a long time, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most fascinating due to its unique characteristics. As Dawn approached Ceres, scientists eagerly anticipated the first detailed photos of this enigmatic world. They saw bright spots scattered across its surface, most notably in a large crater now known as a crater. These bright spots ignited intense interest and speculation among scientists. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photo taken by the Hubble Space Telescope. Experts had limited knowledge of this dwarf planet, and the prospect of finally obtaining a close view was exciting. What secrets would Ceres reveal? What new discoveries awaited? Dawn promised to improve our understanding of the solar system's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny liquids instead of molten rock. But what exactly are these mysterious lights, and what do they reveal about Ceres? Could they be evidence of ongoing geological activity or something even more extraordinary? Ceres differs from other celestial bodies in the asteroid belt due to its size, mass, structure, and potential for water and ice. Unlike most rocky asteroids, Ceres has a structure more akin to a comet, suggesting it holds more secrets about the early solar system than previously imagined. Following 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This moment marked a critical milestone in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn drew closer, the images of Ceres became increasingly detailed, offering glimpses of a world previously shrouded in mystery. The initial images revealed a surface dotted with craters, characteristic of a long history of impacts. However, it wasn't the craters that caught the attention of scientists and space enthusiasts alike. Among these features were peculiar bright spots that stood out starkly against the darker, rugged terrain. As the photos continued to improve in resolution, scientists buzzed with speculation about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something far more remarkable? Closer examination revealed that the brightest spot was not a single feature, but rather a combination of several distinct regions. This discovery only deepened the mystery. The theory that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of transporting water or briny fluids to the surface, where they quickly evaporate, leaving behind bright, reflective deposits. These revelations challenged existing ideas about Ceres, revealing it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres particularly significant compared to other planets? Ceres is a captivating world, often described as a cold planet with a harsh yet delicate surface. Unlike most asteroids in the belt, which are primarily composed of rock and metals, Ceres stands out due to its unique composition. Its surface is a mixture of water, ice, and hydrated minerals, including clays and carbonates, giving it a significantly less dense structure compared to its neighbors. This composition suggests that Ceres contains a substantial amount of water. The surface layer is rough yet porous, with ice and other volatiles trapped within. This icy characteristic is more reminiscent of a comet than a typical asteroid, hinting at a history that may have involved a combination of rocky and icy materials. Digging further underneath its surface, Ceres uncovers considerably additional entrancing parts of its construction. The dwarf planet is accepted to have a differentiated interior comprising of a slushy mantle and a core. The mantle is believed to be rich in water ice, making up around half of Ceres' total volume. This mantle, conceivably a combination of rock and salty water, encompasses a core that might be made of denser material, possibly silicates. The presence of such a significant amount of water ice suggests that Ceres might have once held liquid water, especially if its core was warmed by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and raises intriguing questions about its potential for geological activity and the role of water in its development. However, that isn't all. The discovery of ammonia clays on Ceres suggests that the dwarf planet might have formed in a colder part of the solar system before moving inward. The presence of ammonia lowers the freezing point of water, supporting the possibility of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this fascinating dwarf planet, but also provide critical clues about the processes that govern the evolution of icy bodies throughout the solar system. Cryovolcanism is a unique and somewhat vivid geological process, especially when contrasted with the more familiar volcanic activity on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles like water, ammonia, or methane. These substances can exist as liquids or gases in the frigid conditions where cryovolcanoes are found. On Ceres, cryovolcanoes operate by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with the vacuum of space, it quickly sublimates, transitioning directly from a solid or liquid state to gas, leaving behind bright, reflective salt deposits. These salt deposits form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in an area referred to as Spot 5. This region has drawn significant attention due to its high reflectivity and strange hazes observed by the Dawn spacecraft. These hazes are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity might still be ongoing or may have occurred relatively recently. Furthermore, Ceres has several other bright spots, each with its own unique characteristics. These spots are not confined to one region but are spread across the dwarf planet's surface, indicating that cryovolcanism might be a widespread phenomenon on Ceres. The presence of these bright spots highlights the unique nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges past assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, a wealth of surface features began to emerge. The surface of Ceres is marked by numerous craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an ancient surface that has been exposed to numerous impacts over billions of years. Others are better preserved, with sharp edges and deep basins, suggesting more recent impacts. Curiously, the number of craters on Ceres is fewer than initially expected, which could indicate that geological processes might be renewing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy surface allows for a form of cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of fractures, ridges, and faults on its surface. These features indicate that Ceres' crust has experienced significant stress and stretching. Some of the fractures appear relatively young, perhaps a few 100 million years old, suggesting that the crust is still somewhat dynamic. The ridges and faults on Ceres likely formed as the surface was stretched and pulled apart, while mountain ranges and compressional ridges indicate areas where the surface was pushed together. These contrasting features offer a glimpse into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal pressure or upwelling of materials, potentially related to cryovolcanism. This feature, along with the extensive network of fractures and ridges, points to a dynamic and evolving surface. Dawn's mission has also revealed fascinating surface compositions beyond the bright spots and reflective salts. NASA's data has uncovered a range of surface materials that are crucial for understanding Ceres' geological history. For instance, specific areas on Ceres exhibit a dark, fine-grained material that stands in stark contrast to the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, adding another layer of complexity to Ceres' composition and suggesting potential for prebiotic chemistry. The connection between these materials and the icy surface could play a role in the chemical processes occurring on Ceres. Additionally, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found in carbon-rich compounds. These discoveries are especially exciting since they suggest that Ceres might have conditions suitable for the development of more complex organic molecules. The presence of these compounds opens up possibilities for life, or at least the building blocks for life, on this dwarf planet. Another remarkable feature is the large number of unusual dome-shaped structures on Ceres. These domes, some reaching heights of up to 6 kilometers, are believed to be the result of subsurface processes pushing material through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or internal pressure forcing materials upward. Understanding these formations is crucial for unraveling Ceres' geological history and its internal structure. Additionally, gravity data collected by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of different layers within the dwarf planet, suggesting that Ceres' interior might have complex structures, including a potential subsurface ocean or briny pockets. These discoveries are vital for understanding Ceres' thermal history and its potential to support conditions conducive to life. Overall, the Dawn mission has not only expanded our knowledge of Ceres but also transformed our perspective on small celestial bodies in the solar system. As more data is analyzed, scientists hope to unravel the mysteries of this captivating world and its potential to offer insights into the broader processes that govern planetary evolution and development.